Let me know if you're able to see my screen. Yeah, it's there. So just a quick recap or quick questions. Whatever we have learned in the previous day, is there any doubt from your side? Anyone? Or if you have already gone through it, some particular information from a website with the same whatever we have learned on top of that one. So do you want to clarify any more questions from your side as well based on previous session? Okay, I hope no. So it was fine from your side as well. But if there is any stuck point, please keep asking questions and all. If this is an interactive one, then that should be helpful for everyone. Okay. So today is the day two class. We will be just going to start the database part from today onwards. Just a quick thing. So I also provided the link to download the particular MySQL. There is lots of software available for the databases. So MySQL is an open source one with the free of cost software for the databases. So for the beginner purpose, it's a good one to learn, and you can learn. The installation part is very simple. You can just quickly download and install it. If there is any issue with your installation, you can have this reference link, that particular video. You can check and install it. But it's a very simple one. You can do this thing by your own. I'll be requesting every one of you just to install the same thing at your machine. It will not take more space, and hardly 15 to 20 minutes it should take for the installation part. So from tomorrow onwards, we'll be doing the SQL query um, over here. Then you can do the same thing on as a hands-on exercise at your side too. So that's why I'm requesting you to install this particular software at your system as well. Okay. Okay. So from today's session onwards, I'll be going ahead with some more detailing theory part for normalization, especially. I'll be learning today the keys, that's like foreign key, primary key for a particular table, and some concept of the database as well. So those are today's topic. Yes. So let's maximize my screen over here. Okay. So today we will be, today onwards, we'll be focusing on the RDBMS, the Relational Database Management System. Whatever relational database, we have learned what is relational database. That means we have the tabular structure of data storage. Maybe, there should be some columns, and the record should be inserted as row, each of the row. Okay. So we can go ahead with the next topic. What is normalization? Data without normalization. So suppose we are, at the source system of the transaction. I told you various source system that how the data can be inserted into the OLTP. What is OLTP? I'll be coming to this thing later. Just like the basic transaction. Suppose we have the shopping mall transaction. So basic level of transaction, the data is being inserted into the source system. It's not in normalized in manner. Okay. But to make it a meaningful way, while we are creating the data mart and all, a data warehousing concept there, then we need to make it a meaningful one. So one of the process of making it a meaningful one is to make it a normalized one. The data should be normalized. Otherwise, we cannot able to, go ahead with the particular efficient way of data checking. Okay, because we do not have 5 records or 6 records in our table. There should be millions or billions of records. If we save it in an organized manner, if the data is getting stored into various tables in organized manner, then fetching the data by joining in the SQL queries and all, it should be much easier. Okay, and the database storage capacity will be used in efficient manner as well. Okay. So there is an Excel example of how we can make a data normalized. So let me open that Excel. I think that should be helpful for understanding. Okay, I prepared this Excel for a quick example. Hmm, Make me a bit zoom over here. Okay, so the first table, this one, this is not a normalized one. This is a simple one what I have received from a tuition center. A tuition center, I just got this information. I just collected the stats for this many students. Okay. So this is not the normalized one. We should have to make it in normalized way. We have to decorate it or organize it. So I have prepared it in a organized manner. But what are the steps to do that? That has been mentioned over here. So the first one, the first table, whatever I have received from the source system, it's not a normalized one. Okay. So this is a denormalized table. Let me show you why it's denormalized and how to make it a normalized one. So why it's not normalized? We can see, suppose this one, this two row, we can see the source system or whoever collected this data, it's duplicated over here. Row number 12, the student name is Sonu. The course ID he or she is picking, that is A12, A12, A13, and the course fee he or she is paying 800, 300. The same records is being repeated over here. Maybe some mistake from the source system, maybe the particular person who is collecting all the information, he has duplicated the record. Okay, so this is one kind of thing which is not normalized in nature. Okay, so another reason is there, we cannot store multiple values in a single element, just like this one, A1 to A13 for Sonu. Just like for Raj, A11, A14, and the course fee as well. Just like we can take example, just like for A11, the course fee is 500, A14 the course fee is 700. So this kind of multiple data in a single data element, it's not possible if we are just making it a normalized one. Okay, so it's typically, I mean, denormalized in nature. So we have to make it a normalized one. Okay, so how to make it a normalized one? So over here, I mean, why we need to make it normalized one, that I have already tell you. Data normalization is the process for reorganizing the data within a database so that the users can utilize this particular data for queries. Query means SQL query or any kind of data analysis as well. Data analysis should be much more faster if the data is normalized in manner. Okay. So first of all, what are the steps? Duplication may be eliminated and the result set should be smaller. So it should take the efficient, I mean the storage space should be utilized in efficient way at the database side as well. I mean in database, whatever tables we are creating, okay, it is in backend, it's storing into some particular memory size as well. So I mean how much efficient we can utilize this memory, that should be the main goal from the data engineer's perspective as well. Okay. So and just like minimize, avoid any issues for data modification as well. If we are just going ahead with some data modification, there will be less issues or issue less, we can say as well, if this is normalized in man. And the query to fetch data from the table should be much more easier. So those are the thing. I mean, by which we are going ahead with the normalization process. Now, what are the normalization process? I'm coming to this thing in the next slide. Okay. So based on the normalization process, we put it in three way over here. I mean, two way over. There's like one in a first normalized form or first normal form, and 2NF is the second normal form. There is much more normalized form over here, but 2NF is a standard one that the organization should follow. There is 3NF as well, but as of now, for the basic level, this is not required, and many more organization. Most of the organization used that. Till 2NF at their system while storing the data or while normalizing the data till data warehouse, from source system to data warehouse. Okay, so coming to the topic, what is first normal form? So for the first normal form, the first rule should be each record should be unique. So any such duplication should not be there. And another rule should be there. Each cell should contain a single value. Okay, if we have multiple values in a cell, then we need to split it up to multiple rows only. Okay, so how to do that thing? I'm going to the Excel for the example purpose. So over here, we can see, so first of all, I have eliminated this one. Okay, from here, we can see for the Sonu, only one entry is there. We can see two entry over here, but this is the another criteria. We have two subjects, two courses over here with two course fee. So I have splitted these two into two rows. Okay. So we can see it has been splitted over here into two rows. So, and the same thing over there for Raj as well. Student ID 13 Raj, the course ID has been splitted properly with the course fees. Okay. And this particular row has been eliminated. So now the table, whatever the table structure or table data is there, it's in first normal form, 1NF. Okay, it's a bit normalized, but it's not totally normalized. For make it a normalized one, we have to go to second normal form. Okay, so moving to the next slide. Till now, any doubt from anyone? Any doubt? Okay, hopefully no from your side. Okay, so what are the next topic for second normal form? I'm going to this slide. Okay, just okay. So the criteria for going ahead with the second normal form, the first criteria should be always the tabular structure or the table's data should be in first normal form, which we have already done in this example. And the second point and the most important point is removal of partial dependency. So just like this one, if we just take an example from this table, we can see over here student ID, student name, course ID is there. Okay, so the first three columns is related to on a particular student, how that particular what is the topic that particular student is having over here and everything. And course fee do not depend on directly on student. Okay, course fee is a separate topic which is dependent on course ID only. So if we have any partial dependency, any columns which is not dependent with the primary keys, I'll be coming to the point. What is primary key? Quickly. So over here we can say the primary key is in that particular topic, the primary key student ID. Primary key should be unique. So 11, 12, just like a roll number. Roll number is a primary key. But in that table, this is not a primary key because Sonu is having two particular course ID. That's why it's been repeated. Student ID is repeated in 12, 12. Over here 13, 13. So here student ID and course ID's combination is a primary key. We can say 11A11. It's not repeated over here in any of the rows. So on top of that thing, the course fee is not a dependent column over here. Okay. Can you able to hear me properly? I found a quick message that my internet is not well. It's fine. Voice is clear to everyone. Anyone? Okay. I hope yes. So, as the course fee is not directly dependent on each of the column or the primary keys of that particular table, so we can split this course fee into a separate table. So this is called to make it a second normal form. Okay. So how to do that? We can see course fee over here. Let me zoom out a bit over here. Okay. So we just keep the first three columns in a single table. Okay. And split the course fee with course ID. So we can see if we just put the entire thing over here, we can see it's repeated. A14 is repeated because Raj and Peter is taking A14 and it's been repeated. That's why for this table, we just have the distinct one or the unique one and we have put in this manner. So now combination of these two tables, we can say it's a second normal form of the particular source table. Okay. So it's understandable. So now this combination of two tables are normalized in nature. So just like if we want to see how much thing Sonu needs to pay for this particular tuition center, we need to check these are the course ID. Then we need to, join these two tables based on this course ID. So 800 and 300 total. We can do on some aggregation operation in the SQL side. So it should be 1100. Okay, so this way we can quickly measure. So it's efficient to store the data at the database because we'll not be working there for this 5 to 6 records over there. There should be millions of records. The storing efficiency should be great. And while fetching the record by SQL query, it should be much more easier and time efficient as well. Okay, so that is the thing, that is the purpose of make it a, make the tables a normalized one. And in future as well, if you are working as a data engineer, definitely will be, if you are just going ahead with some interviews and all, they will be asking for this kind of normalized, how to make it normalized one, and they can give you some example and all. And you can definitely get these questions as well. You can also face this kind of scenario if you already working in such kind of business solutions and all at your side. Okay. Hopefully that is understandable. I'm going to the next slide. If there is any issue, please tell me. If not, I'm going to the next slide. Okay. So keys in SQL. So each of the table we are having this kind of key concept over here, and this is much, very much important concept. So that should be useful in our future session as well. So I'll be requesting you to, if there is any questions or anything, you can quickly ask me. So there are three kind of keys. One is called primary key, one is called foreign key, another one you can say composite key. So what is primary key? So for a particular table, just like for this one, the normalized one, there should be a column identifier. Okay. By which particular column we can identify the entire record. So the primary key should be unique in nature, and that cannot be duplicated, that cannot be nullable as well. Primary key should be always a not null record, or not null data should be entered over there only. Okay, so over here we can see 11, 12, 13, 14. Okay, no, it's not primary key because 12 is a duplicated. Yeah, that is fine. So from the normalized purpose, if we check it, student ID should be a unique key over here, but it's not unique key because 12 is repeated. So that's why we have to take into consideration a composite key. What is composite key? We can take multiple columns combination to take it a key. Okay. Just like, sorry. Just like over here, we can see for the student ID and combination of course ID. It's not duplicated over here. Student ID Pankaj and course ID A11. This should not be a duplicated one. So we can say multiple things over here. The composite key of student ID and course ID is a primary key. We can see it's not duplicated and it is unique in nature. And based on all the data, we can signify the combination of two data is the row identifier of that particular table. Okay, it's understandable. I think so. If not, please tell me what is primary key and what is composite key. I just told you over here. Now I'll be coming. What is foreign key? Okay. Okay, fine. So the same thing for this table as well. Student ID and course ID's combination is should be a composite key as well as primary key. This particular table, the course table, over here we can confirm that course ID is the primary key. Okay. So those are the primary key for each of the table. Now what is foreign key? Foreign key for that particular table, foreign key is this one. When we will be joining between two tables based on some common columns for these two tables to fetch what is Pankaj's course fee, we need to join this table based on course ID to get the appended records or to get the entire records. What is SQL join? I'll be coming to this thing later. Join means to join between two tables to get information from the other table. Okay, so we need to join these two table based on the common column which is course ID, and for this course ID we can pick it up what are the courses fees. Okay, so irrespective of this table, course ID is the foreign key. Course ID is the primary key for this table, but respective of this table, we can say course ID is the foreign key. Similar way, for this kind of table, the combination of student ID and course ID is the foreign key. So this can be the concept. Okay, hopefully you can understand it. If not, please ask me again if there is any issue or any doubt. Okay, hopefully no. So now we have understand what is foreign key, composite key, as well as the primary key. Whatever, why we have learned it, because that should be used in our future session as well when we'll be creating some data modeling in the latter chapters based on join. That should be also useful when we'll be performing some join operation in the SQL side between two or multiple tables and all. So those are very much important concept, and we need to choose properly what are the primary key for a particular table, what is the composite key for that particular table, what should be the foreign key and all. Okay, so those are very important. If you are not able to understand, please tell me, or you can also check from the website as well what are the things, and you can find in more detailed manner over there. But if there is any doubt, keep asking me. Okay, so moving to the next slide, the database. Okay, so what is database? Let me maximize the screen.
Suptik,
Yeah, tell me, please.
so always when there is a table which consists of composite key, definitely there is a primary key in it, right? So it's a so whenever there is a composite key, there will be primary key. And
Correct.
uh,
Correct.
and and in the other table, as you showed, composite key can be a foreign key as well.
Yeah, the concept should be coming into this manner. But if we are just taking this thing as a main table, the student table is the main table over here. So
Mm-hmm.
specifically, we can say the foreign key for this table should be the course ID over here. The vice versa
Mm-hmm.
is not appropriate in nature, but just a quick example for the basic reference, we can say that thing. As if we just take this thing as a main table, we need to join to with this table, but this is, I mean, ideally this should not be the case. This is the main table, and we have splitted this thing as a subset. Okay.
Mm.
Ideally, we should not speak that the combination of student ID and course ID is a foreign key respective to the this, but conceptually we can say it if we take it as a main table and we are joining, we are picking up this thing as a reference to get what are the course fees for the students. So then we can say this can be a foreign key. For this scenario or this example, ideally it should not be because this is a main table and this is a subset of the table. Okay. But conceptually, we can say yes, the combination of the particular two column can be a foreign key. Okay. Is it understandable properly or can I explain it in more depth?
Uh, no, for this example, I understood. Maybe going forward with another example, I think I'll get more clarity. Now I understood.
Okay, so specifically, the vice versa thing you can just remove from your mind. So just, I
Mm-hmm.
mean, foreign key example, the
Mm-hmm.
main table. This is the main table. This is I mean, we splitted recently this particular course table from here from the student concept. So for this table, the foreign key should be the course ID. We can say this thing.
Yeah,
The vice
this
versa
makes
thing as of now you can remove. So because I mean we want to know. I mean how the question should be coming. What are the courses fee should be paid by Pankaj? Okay. Then we need to join between these two tables. Suppose we have millions of records. So we need to join between two tables based on the common columns, course ID and course ID over here. So when I'm joining with the main tables with the other tables, what are the key references based on we are joining these tables? This key reference is called the foreign key. This should be the definition or concept, the main concept. Okay. So
okay.
respective to this table, this is the foreign key. As of
Okay.
now, for this example, we can remove whatever I was telling. So for this table, whatever I was telling, if that is the main table, for this scenario, this is not a main table actually. So if we are joining between these two tables, then the combination of student ID, I mean that composite key, we just let me remove that thing over here. Delete cells, I think that should be working. No, I should be delete cell right. Okay.
Entire column. Yeah.
Okay, so just put the combination of this thing in a single manner. So this is a key. This is a key. Actually,
Mm.
this should not be the foreign key over here, but conceptually we can say, I mean, I just want to mean that if the main table, when we are picking data from the second table, so which key references we are joining, so that should be the foreign key.
Foreign
Okay,
key.
yeah.
Okay.
But this combination, 1 1 and A11, 1 2 A12, it's a primary key for this table as well as the composite key, you can say. The combination of these two is a primary key for this student table. Okay, fine.
Yeah.
So, okay, thanks for the questions and whatever you have learned. I mean, I mean, it's a good questions as well. So it's fine.
Yeah. Thank you.
Yeah, yeah. Okay, so coming to the next topic, what is database? So the main thing will be operating from the tomorrow sessions onwards. That is the database. So we'll be doing SQL queries and all on top of that one. So database is specifically we're storing data there. Okay, so it should be hosted into some server. Obviously, it may be a Linux server, it may be a Windows server. So and we can easily fetch the data from that particular database by using the SQL queries and all. Okay, and I mean we can store the data in the Excel as well. that particular data is there. This is also a relational database because we have the columnar structure over there and all. But for the practical purpose, I mean, if we have lots of records and we have to fetch quickly, we can see, I mean, we can do the control F part over here to fetch the data. There are suppose hundreds of records or thousands of records. To fetch a particular student ID's information, we can use control F. Okay, so that kind of things we can do. The same thing, I mean, but this is not the efficient way to store the data over here in Excel. And also, if we have lots of records, maybe millions, billions of records, we cannot store it over here. So that's why we are designing. I mean, not we, actually, the database has been designed over there, or this is the concept for storing data there so that we can fetch the data easily as well as we can store it in proper and efficient way. So that is why this is the concept of database. So in my local server, I have installed this MySQL. Let me open that one. MySQL, where is it? Yeah. So this is the software, MySQL Workbench. The database is there already. I have installed it. And this software is a user interface to check the backend data. So I'm opening MySQL databases. I mean MySQL Workbench. Okay, it should be look like this. I have also already give you that link to install it. So that particular thing has been installed in my local system. Okay, so that's why it's local host. And to connect each of the database, there must be a credential. So by default, if you installing it, the credential, the service account of the particular user should be root. And the port for this particular database should be 3306. So by default, MySQL is having port number 3306 and there must be a password authentication. This is a database. I'm going to double click on it to connect the database. It's asking me the password. So password is required for the first time installation. I mentioned the same thing in the video that I have referred there. So just you need to give that password. Let me think for mine. Okay. I am able to enter this database. Okay. So this is the database we have able to connect. So over there we can see those are called schema. Inside that particular database, those are the various schema. Why schema? I mean separate schema we have created. Schema is for storing data. I mean suppose for each subject area we can create separate schema and we can store the respective tables for each of the schema. Just like this is the this that if you just install it, you can see those kind of C's, world, those are the by default schema should be there at your side as well. Okay. But for this training purpose, I have created this schema over here. So how to create schema? We can just create directly on over here. We can create schema by, I mean, clicking on there, create schema, and you just have to give a schema name there and press enter. Create schema. The new schema name you can put anything, just like test. Okay. Whether it's a default schema means whenever you will be logging in, that should be your default or not. So you, in block letter you can see data training purpose. I have make it a default one. So just apply it and the test schema should be created. And we can do this thing at the command prompt as well. The command should be create. Create is a keyword. Schema is a keyword. Test is the name, the user defined name that we need to put over here. Whether it should be a default one or not, we need to do the same thing. I have applied it, finish it. So we can see the test schema has been created. So we can create all the tables over here, views over here. Those are the several component. I mean, those are database component. But specifically, we will be more focusing on the tables over here. In the, latter chapters, I'll be touching up what are the other components. There are views, store procedures, functions. I'll be touching this thing in the latter chapters, but the main focusing for the crash course over here is how to store the data in tables or how to create new tables and all. Let me drop that schema. This is not required. So we can run drop schema name or directly drop from here. Those are the advantages of using user interface EUI over here. Okay. So where was I? Yeah. So in database, we can store the data. We need to create the schema first and I'm opening the schema, and in the table option, those are the different component or database component we can say. So I'm just expanding tables. So those are the various tables. Okay. That I have created. Employee 1, EMP1, EMP2. I'll be dropping this thing before tomorrow's session because we will be start learning how to create tables and all. But those are the way we am storing the data, storing the table inside the database schema. Okay. So that is called database. What are the different kind of databases I just put over here? MySQL, Oracle. For the Microsoft, to have Microsoft SQL Server, Teradata, Postgres. So those are new database as well. Hosted in the cloud platform. Sybase, DB2, Redshift. There are various kind of database. Which kind of database we should be working, it's totally dependent on the project's architect and all. They will be checking the cost efficiency or the best way to represent their data, and they will be choosing any tool at their side. But the main concept of database is always same. Maybe some syntactical changes is there for each of the databases, query languages and all, but it's 90% or more than 90% is it's similar. So if you have the concept of the particular query language or on top of database, you can work in any of the database. Maybe sometime you need to search it from Google, what is the exact user defined function syntax, or what is the default inbuilt function syntax. So that is easily available in the portal as well, but the basic concept you will be learning. There will be no issue. Okay, moving to the next topic, database schema. Yeah, that I just covered. Those are called database schema. Over here we can see those are inside the particular database we have those schemas available where we are storing our data in tabular format. Okay, and another topic is there, the database objects. Whatever I have already covered this thing as well. The table should be the basic unit of storage that should be composed of rows and columns. And views, there are other things as well. Not only table is the main the main unit for storing the data, and we'll be mainly focusing on the tables only, how to create tables, how to and do analysis on top of tables and everything. There are various ways to store the thing as well. Not storing purpose, just like indexing is a thing. I'll be coming to this thing later. Synonym is a thing, sequence is a thing. Lots of things are there, but those things I'll be gradually coming into the latter chapter. Maybe at the end of the SQL query, I'll be touching this thing. Okay, view is another way to logically store the data as well, and it should be combination of tables. Okay, in store procedures, there are store procedures. I did not mention it over here. You can see store procedures. It's we can put logical syntaxes over here to do some analysis on table operation. Okay, so those kind of component will be coming in detailed manner. From the next day onwards, we'll be working on top of tables. So how to create the table, how to alter the table structure and all, how to manipulate the data inside tables data. So those things we can cover by SQL language, that is called structured query language, over here inside the same database. So I'll be requesting you again. So whoever did not install that particular software, or if you have any software at your site as well already installed, then it's fine. No need to install the thing. But whoever doesn't have any software, you can install it just for a quick learn. So when that thing should be, you will learn it, then you can uninstall it as well. But install it because this is a basic needs for our data engineers. Okay, to do the query on top of data. Hope excuse me. So I think that's all for today's session. Tomorrow onwards, we'll be learning inside everything in the database, and everything should be hands-on exercise over here only. Okay. So any doubt for today's session till now? Okay. Hopefully no doubt. So let's connect tomorrow with the details on top of the tables and all, how to create the tables, the DDS, DMLs, and everything. So, and that should be hands-on as well, and it should be more interesting. Okay. Okay, then. Thanks for today. Thanks for attending the session. So, let's connect tomorrow for the detailing part on tables. Thank you, everyone. Bye bye. Have a great day.